Welcome to Data BS, a show dedicated to tackling the big questions impacting the world of data and ML/AI without any of the BS. My name is James Winegar. Each week I sit down with guests from across the data ecosystem to unpack how they're shaping their businesses or the businesses of others through the real-world application of data engineering, ML/AI, infrastructure, analytics, and more. No fluff, unfiltered, but slightly edited to remove noise. This is Data BS. Let's get into it.
Thanks for joining us, Toby. Can you tell us about yourself and how Tobiko came to be with SQL Mesh and SQL Glot?
Sure. Thanks for having me, James. Yeah, so my name's Toby. I'm the CTO and one of the three co-founders of Tobiko Data. We make SQL Mesh and SQL Glot, two newish tools in the data transformation game. So, I kind of got my start in data, doing a lot of data work at Netflix, where I led the experimentations teams. So I worked a lot on big systems like Spark and Presto, building out data science and analytics platforms there. After that, I moved to Airbnb, where I started to work on Minerva, their metrics platform, as well as their experimentation platform. And so I kind of saw what it takes to build a data transformation platform that can work at a company like Airbnb, and decided to give it my own shot to kind of take what I've learned and build something for the public.
Yeah, so the similar ideas that you had to do from scratch internally, you were able to apply and then put towards an open source framework, or you're trying to take all the best approaches that you thought really needed to be there?
Yeah, it's definitely the best of all approaches. I think that a lot of the things that are done at FANG companies might not apply to most people in industry. So, for example, one of the things that we did when we first started SQL Mesh is that we thought that our primary audience would all be using Spark and Airflow. And so that turned out not to be true. Most people are using things like Snowflake and BigQuery and Databricks. And so I think that as we went further along with building out the product and the company, we learned a lot more about what most people are looking for.
People are a victim of their experience, and when you don't see 1,000 different things, you kind of got here's the 3 or 4 places I were. It's all very heavy tech, and then learning kind of what is most used, and then kind of identifying your ICP from there, right?
Yeah, exactly.
So what was the real trigger to spin up SQL Mesh for you? I'm guessing something that happened at work.
Yeah, so kind of I always wanted to start a company. And initially I was thinking about building out a semantics layer because of the work I had done with Minerva. But then I realized that the true power of Minerva wasn't the semantic layer. The semantic layer is cool, but Minerva was really useful and powerful because it was a transformation framework. So while I was there, I got a demo of DBT, and I just started asking a couple questions well, it looks like you're just refreshing the database every time you do DBT run. How does that work? It's oh, well, you can just refresh everything. I'm well, that would never work here. We can't do that. Or what if I just want to run 1 day of data or this time range of data? It's you don't do that. You just run everything. And so from there, I started doing a little bit more digging, and I was well, this tool seems to be pretty popular and there seems to be a need for data transformation tools. Why don't we try to kind of build something that can scale at any company and be just as powerful? So that's kind of why we started it.
Identifying the gap in capability and then build out from there, pretty much.
Yeah, exactly.
So I think that transitions pretty well into a high level outline of why incremental processing is necessary when you have large scale, maybe from a time series viewpoint or something like that.
Right. So I think DBT is really great when your data is simple and you can kind of have a fully stateless warehouse. So if your data is small and you don't have that many models and you're able to just either make everything a view or fully refresh everything, it's really nice because it's very simple, and you don't have to worry about anything. You just do DBT run and everything's good. Everybody's happy, right? But working at kind of larger scale, especially at a FANG company, you can't do that anymore. There's just too many tables and the tables are too big, right? And so instead of refreshing, for example, the table that tracks every single video play at Netflix, you have to start processing things every day, right? 1 day at a time, or even every hour, 1 hour at a time, because each day might have petabytes of data and you can't just refresh years of petabytes of data, right? And so once you start doing incremental processing, it gets a little bit more difficult, right? Because there's state involved. you want to know which dates or which intervals have been processed. You need to keep track of that, and you want to only do what needs to be done, right? And so one of the core differentiators of SQL Mesh is that it has first-class understanding of state, right? Every time you run something, it kind of fingerprints and tracks that, as well as it stores when you ran things for and then what needs to run next, right? So every model in SQL Mesh also has a concept of cron, right? And so it's got built-in scheduling capabilities, as well as tracking of when those things need to happen and what has already happened.
And then you're saving that into the warehouse itself, some like state table. And then that way you can reference it or
Yeah, exactly. So by default, we wanted to make SQL Mesh work out of the box. And so you use the same warehouse for state. So for example, if you're using BigQuery for your engine, we store all this extra metadata into the warehouse. But warehouses aren't really designed for transactional processing. So things like for every run, keeping track of the state or whatever. And so you can optionally set up a Postgres database, which we suggest, or you can use our new cloud offering, which has hosted state.
yeah, which is a Postgres database under the hood.
Exactly.
So.
A Postgres.
Is it only Postgres? Is it support for the state management layer, or do you like support other things for that?
Yeah, we support other first-class transactional stores. I think some people use MySQL with it, but most of our testing is done on Postgres, but MySQL should work.
Postgres is kind of like it just works for the vast majority of these things, and the only reason people would use MySQL is like, they got 1,000 other MySQL databases, and they don't want to have to think about the difference between Postgres and MySQL for whoever has to manage it.
Well, to be fair to MySQL, I believe like it has better sharding capabilities, and so like companies like Uber, I've read that they choose MySQL because they can heavily shard and have multiple databases.
So one of the reasons I really like SQL Mesh in particular is like compile time checks for your model. So like, could you talk to what besides incremental processing, things like that, like what really makes SQL Mesh like support the developer efficiency more effectively?
So one of the big value adds of SQL Mesh is that it's built on top of SQL Glot, which is an open source SQL parser and transpiler that I built a couple of years back. And so what that does is it gives SQL Mesh the ability to actually understand SQL, right? So traditionally, many other ETL tools or data transformation tools, they don't really understand SQL. They kind of just stitch together SQL with Jinja, and then they just send it to the warehouse, right? And it's up to the warehouse to decide what's right or wrong. With SQL Mesh, we took the opportunity to build it from the ground up to understand SQL. So when you actually do a SQL Mesh plan, which is kind of similar to a run in dbt, basically it compiles all your SQL and understands it. And so if you have a syntax error, like you're missing a parentheses or something like that, or you don't pass in the right argument to a function, it'll say, hey, this doesn't look right, right? And so instead of having to execute 10, 20 models, and then for your 21st model to say, hey, you have a syntax error, right? Wasting all that work, SQL Mesh will say, hey, you broke this, fix it, and then it will run. So it won't do any processing. But again, going back to state, right? So in that example of the other framework, right, with dbt, let's say you made some kind of error, right? And then you processed 20 models and then your 21st model errored. If you just did dbt, after fixing it, if you just did dbt run again, you process all those models, right? Because it doesn't know what has been done. With SQL Mesh, we catch a lot of errors, but we can't catch everything, right? Because ultimately, it's up to the data warehouse to be the source of truth. And so even if that happens with SQL Mesh, you get to the 21st model and then it errors. If you rerun it again, it's only going to start from there. It remembers where it last left off.
Or it might run the next increment because it was an hour later and based off your incremental. So
that's another benefit of SQL Mesh, right? I think dbt recently launched kind of they call it batch incrementals. And that's similar to our native incrementals. But because they don't have a concept of state, if you miss an interval, so let's say, you had to process 12 p.m., but it's been an hour, so it's already 1 p.m., you're not going to process 12 p.m. You're going to skip it. There's going to be a data gap. With SQL Mesh, when you run it and it's 2 p.m., we'll know that 12 p.m. and 1 p.m. haven't run yet. And so we're going to batch all those up and run all those together. So you never have to worry about manually defining what needs to run.
Yeah, in that you're going to run 3 different models, the 12 p.m., the 1 p.m., and the 2 p.m. like increments.
Well, so that's so many differences, but another difference with SQL Mesh is that it can batch them up. And so instead of having to run 3
Oh,
separate
so
jobs.
dynamically like
Yeah,
taking the windowing time, as long as like you don't set up maximum threshold or something for volume reasons, right?
exactly, and
Yeah,
you can control that as well, like, that's a toggle, but by default, we would just run 1 job from 12 p.m. to 2 p.m.
yeah, and then you're just watermarking that in your state table,
Exactly, yep.
basically. Yeah, I learned something new now. I would have figured it would have done 3 different jobs to kind of manage like the interval. If you have a failure due to, I don't know, like let's just say you're running on an extra small snowflake or something like that, and you get like it crashes out for whatever reason, like timeout, because you have a 10-minute timeout on the query or something. Will it try to shrink in the interval time?
Not right now. There's so many different things that can go wrong, right?
Yeah,
It
you
could be
don't know if
worse.
it's you kind of
Yeah,
thing.
and so, as of now, you can just, change your batch size. We call it batch size, and so you can make that, for example, 1 hour instead of 10 hours, right? And then you only
Yeah.
process 1 hour at a time.
And then you guys can group it or, based off the toggle that we were talking about before.
Exactly, yep.
So, yeah. Awesome. And is that like maximum number of batches or something like that is the toggle?
Yeah, so we have a concept called interval unit, right? And that kind of represents the time grain of your model. So by default, it's daily, right? So if you say that you have a batch size of 10, that means every time you run, you can run a maximum of 10 days per job.
Yeah. Depending on whatever you define your grain. So it's like the interval multiplier by the grain,
Exactly.
basically. Okay.
That's right.
And then you guys, because you manage state, you can handle that
That's right.
dynamically pretty
Mhm.
much. What other things kind of come to mind for you?
I would say like innovation or differentiator of SQL Mesh is what we call the virtual data environment. And so we wanted a way for SQL Mesh to enable developers to very quickly be able to work on representative data. So at kind of Airbnb, Netflix, and basically every company that I worked at, developers develop on production data, whether or not you like that. Because, for example, if you're writing a machine learning model or you're trying to compute statistics or analytics, doing that on fake data just doesn't really work because you don't know what you're working with, right? It's not representative. And so traditionally at these companies, it's hard, right? Because you have to like manually point to the right tables in production, make a copy, right? It's expensive. And so because we have state, right? Because we can track things, we know what the definitions of models are. When a developer in SQL Mesh creates a new development environment, basically we can do automatic like creation of the development environment without doing any work. And so the way we do that is through views. So SQL Mesh has 2 layers. It has what we call a physical layer and a virtual layer. So the physical layer is basically machine managed. You don't have to worry about it, but basically it's a bunch of hash tables, and that's where all your actual materializations go. So your tables, your views, they all go into there, but they're hashed with a special fingerprint. And then on top of that, we have the view layer. So your actual prod environment or your dev environment are just all views, and they're just pointing to one of the physical tables. And so when you're creating a dev environment based on prod, you don't have to do any processing. It just creates a bunch of views mimicking prod, pointing to the right tables. And then so when you make a change in dev, we'll understand, okay, you changed this model and these dependencies. And so it will just create the physical tables that are necessary and then repoint all those views to the physical tables
Yeah, for the dev one,
for
right?
the dev one. That's right. And then finally, when you're ready to go, like you've double checked everything, CI/CD is good, green, right? When you want to deploy it, again, you don't have to recompute anything like you would with other frameworks, right? We would just in prod swap all the view pointers that have changed to the new physical tables, right? And so you can get instant data deployments and even instant rollbacks.
Because under the hood, like you've already done the work, right?
Exactly.
Because you're operating on the production data set, because that's the only way you're really going to be able to be like, oh yes, this piece of information makes sense, and you're using like Hashboard or something. And do a preview deployment on that, and you can look at like how BI got impacted. Okay, yeah, we're good to go with that. Now I'm going to merge it. Well, I already got the data transformation I've done, and now I just changed the pointer. So this all backs out of you have the ability to keep track of state. And
That's
because you
exactly
have
right.
the ability to keep track of state, there are other things that you can handle for the developer.
That's exactly right. So it's a huge efficiency gain. You can start building representative data, and then for the first time in data development, you can actually promote data that you've been working on to production. Like you can actually promote a table now. Instead of having to just promote code and then rerunning everything, you can actually just elevate a table to be used.
So I got a different question then. What about pruning of like the physical layer? Because like I did a bunch of dev work, like some of it, I throw away. I don't need it because I messed up my window function, like those types of things. Like how does SQL Mesh help with the cleanup process?
Yeah, that's a great question. So obviously, as you have more development environments and you make changes, right, you're going to have more of these physical tables. So that's why each physical table has a property called a TTL, right?
Okay.
Time to live. And so that's by default 1 week. And so basically, every time you run the janitor, it will check for any table that's over a week old that's not being used, right? And it will delete it.
Okay, so you're just pruning in the background, basically, like, hey, this table's got TTL of whatever, so and it's been longer than whatever,
Yeah,
so now it's time to just truncate the table and delete it
right.
out.
And it's not being used in production or
Yeah, you got
anything
all
like
the
that.
checks because you have all the
Yep.
state,
Yep.
basically. So
Exactly right.
I want to do like a moving average for some column, and I want to make that a new column. And so I have, like let's just assume we got a petabyte of data for giggles, So I'm not going to be able to do that in a single kind of like batch or whatever. So I have an analyst or data engineer or analyst. I would pick your person. They update the SQL mesh model to have this moving average transformation on like I don't know price or something like that. And in the development environment, I'm going to do all that work. And there's a bunch of partitions there that it has to go over for each of the increments because the data set is large. Is there any work that happens where you're able to say, oh, I've already done that particular work in a different transformation somewhere, bring it out? Because like a lot of these data warehouses are column based, so I could pull out that column to use as a reference, but that also might be janky because that involves like bringing together a join or something. So is that kind of throwaway like during the dev cycle? If you got these transformations that you're working on, you have a larger data set, you still need to be careful is really where I'm trying to go with that, about like not wasting a bajillion compute units or whatever.
Generally, with data transformation tools, you want your code to be idempotent and you want your code to be self-containing. And so like you don't want to create a table with ad hoc SQL, right? You want to create a table with SQL that's written in your transformation framework so that it's get checked in and all that kind of stuff, and then you can recreate it, right? And so when you're working on something in dev with SQL Mesh, you put it into a model and basically run it. And so, like, a couple of things that you can do to make it more efficient are one, first of all, in dev, you can just run one day or one time window at a time. So you're not processing too much data and you can test it and make sure that it scales. But two, like, there's a couple of other things that we can do to make it more efficient. One is you can do a self-referential model. So you can refer to yourself to rebuild the net computation. So for example, if you're computing something like lifetime revenue, instead of computing lifetime every single time, which is a full scan, you could just look at yesterday's data. And then from yesterday's data, you can then add today's data, right? So that's something you can do.
Yeah.
But one of the tricky things with that, right, is that now your model, refers to itself. So it can't be run in parallel anymore. And so because we can parse SQL, we can detect that automatically, and then we'll automatically switch your model to be sequential. So that's like an example of another really nice
You
kind
don't have
of
to think about it
exactly.
as an analyst or
That's
whatever.
right.
Somebody else already knew that you would break it if you did that. So therefore, yeah, we're gonna flip the switch for you instead of you having to think about it. That's a really hard problem. Like to minimize computation
Uh-huh.
while also allowing for the thing to evolve effectively. Are you seeing with SQL Mesh, Tobiko customers? Are you seeing them even their dev cycle is happening in CI/CD?
Yeah, absolutely. So we have a open source GitHub CI/CD bot, and so we see many companies using SQL Mesh in conjunction with CI/CD, right? And so a lot of people when they do development, they do that locally, but in order to get something to production, right, you have to go through a PR process. And so when you make the PR, the bot automatically creates a PR environment. And so what's nice is that it runs all the checks and runs all the evaluations, but then people can actually look at the environment to see like what that data looks like, which is really nice, right? And then once you get the required provers and it passes the checks, when you merge it, the bot automatically also promotes that
Production.
environment to production.
And then because you have state management, you're able to manage that whole workflow. It's just another virtual data environment. You do the incremental transformations or whatever you need to do. You might have to do some history based on what it is, and then just go through the merge process that you have.
So we've worked with a couple of different companies that used to use dbt for a long time, right? And so one of the amazing benefits that we've seen is that you actually get a true data deployment. So what does that mean, right? So with dbt, usually how it works, right? You do a PR, and when you merge the data in, that's kind of like now in production, right? When you merge in your code in the main branch, your next dbt run is going to kick off and it's going to run stuff. Now, if you broke something, right, your production is now broken because when you do a dbt run, it'll crash, right? But with SQL Mesh, you can't change the production deployment until it actually runs. And so even if you were to mistakenly merge something into production with broken code, if it crashes, it's not going to affect production. And so production will be on the previous version that still ran.
It'll just be stale or something
Exactly.
like
It'll
that.
just be stale. And so for the first time, you've got a real data deployment, right? Which is pretty powerful.
Yeah. Instead of having to do like some of the things we've done before is like, I'm going to have a step where basically I build everything into a particular database or a particular schema or something like that. And then the last stage is actually a promotion lifecycle management. But that's complicated because now you're, kind of managing a bunch of state, in SQL, which is not exactly the best place to manage states. So,
Right.
there's always something happens. Can't cover every edge case in what I am talking about. And so
Exactly.
by forcing the, run completed successfully, promotion cycle, you don't run into a place where even like let's just say you have like data test cases, right, that start to fail because new data comes in that's not meeting expectations. Well, you can keep your production environment just stale while you try to do an investigation. So it's
Yeah,
it's
exactly.
not even something that's like dependent on the deployment process. It's also dependent on like your data verifications and things like that you do. Because in a lot of cases for us, what happens is like there's an engineer on a software product doing something. They make a bunch of changes. They change like fundamental like ideas about the data. Maybe they do a big migration in the application layer. Nobody told the data team that, hey, we changed like the way that this compound ID is actually generated. And so your split logic or something like that doesn't even make any sense anymore. And then that ends up in your warehouse, and then suddenly your test cases aren't passing. Well, then you don't actually promote on that run to production. Am I understanding that right?
Yeah, so the kind of deployment process can be done in different ways, but basically, you got to make sure your code compiles, right? All the SQL's good. Then you got to make sure that the code actually runs. And then once that's done, once you've actually created those data assets, then you can promote, swap all the pointers. And so all of this is done again with representative data. You might be able to build a custom thing with dbt to do this, but you're probably going to do it in different target warehouse, right, or different target database. And so again, it's not really represented data. And just because it ran in your target database doesn't mean when you actually merge it to main, it's going to run on your production database, right? And so there's just like a lot of gotchas to be had if you don't have virtual data environments.
Is there any other, kind of particular things about SQL Mesh that you think really impacts the dev workflow?
So combining state SQL parsing, a deep understanding of SQL, allows us to do really, really powerful things. And so SQL Mesh has a concept called breaking and non-breaking changes, right? As an example, if you're working on a table and you add a new column, right? Nobody else uses that column downstream, right? So that's a safe change. And so SQL Mesh automatically says, hey, this is a non-breaking change, right? We can backfill this table that you added this new column because it's new, but nobody downstream uses this column. So we don't need to backfill any of those, right? And you can see SQL Mesh is smart and understands what happens and what needs to happen. And so it saved you a ton of computation because you didn't have to recompute all the downstream things. Now, if you were to change the where filter or add a join, that's a completely different story because all the downstream models could be affected. Their cardinalities could change as well. And so we call that a breaking change. And so understanding state, right, gives us the ability to understand what has changed, right? Because state allows you to know what it was before, and then when you change it, what it became. And then understanding SQL lets you say, oh, okay, you added a column here. It's okay. Or you changed the where filter. That's not okay, right? And so combining those two things gives us the ability to automatically only run exactly what is necessary.
Yeah. It's a minimization of the compute utilization as well. Also minimizing the iteration time, because like one thing that happens is you have sufficiently complicated project, it takes 2 hours to run or whatever, right? And so, like if I only have a small non-breaking change, I really only need to look at this one table. And that might be like fairly easy to do, relatively speaking, in terms of like compute time. So I think let's switch gears to, you had already talked about SQL Glot a little bit. And so one of the things I really like about SQL Glot, which is kind of independent of SQL Mesh, but also can be used within SQL Mesh, is the fact that it standardizes the way you write SQL in a way that like allows you to have a given model or whatever that it's written in Snowflake syntax or BigQuery syntax, but you can because SQL Glot understands SQL, it can transition that to DuckDB or Redshift or whatever other target that you want to do. And so it really eliminates a lot of vendor lock-in with data warehouses. So I kind of wanted to hear your thoughts about SQL Glot and how that ties in with different migration strategies that people might run, and how SQL Mesh really like enables companies to be a little bit more independent of their providers.
So I created SQL Glot when I was at Netflix because at Netflix and many other companies like Netflix, they use multiple database engines. So at the time, they use a lot of Spark, a lot of Presto, and Druid. And data scientists like to write SQL, but they didn't want to write the SQL 3 times because Presto, Spark, and Druid are all very different syntaxes, right? And so SQL Glot was created so that when someone writes a Spark query, we can actually transpile that and then run that in Presto, right? And so SQL Mesh basically automatically gets that capability. So if you have a bunch of models written in Snowflake or BigQuery, you can actually run all those queries in DuckDB. And so we leverage that ability to give you, for example, a unit test, right? So in SQL Mesh, to save money and make iteration speed faster, instead of running all your queries against real data in the warehouse, you can run all of your queries against fixtures or fake data, right? Basically YAML files or JSON files of fake data, and basically assert for expectations. So you're like, okay, this query given this data set is going to return this data set, right? And so what's nice about this is that it gives us the ability to kind of run a SQL query in any warehouse we want. And instead of having to re-implement, for example, every warehouse ourselves, like trying to actually run BigQuery code or having to run Snowflake code, we can just use a nice engine like DuckDB that does all the work for us. So we just really have to translate the SQL queries. Now, what we've seen some of our customers do is they want to avoid vendor lock-in, right? So they love the unit tests, right? They run their things in DuckDB, but maybe a warehouse really starts increasing their bills, or for some reason they want to switch from warehouse A to warehouse B. Well, with SQL Mesh, it gives them that flexibility because now they can just take all their models and direct them to a different warehouse and you're good to go. So that's one part of the story, right? Just running the queries that you wrote in a dialect to another warehouse, right? But after that, you want to make sure all the data is correct, right? Because there might be differences in types, right? Maybe floats have 5 digits in one warehouse and 4 digits in another, right? And so SQL Mesh also comes with data diffing, right? And it gives you the ability to check whether or not 2 tables are the same or not.
Across gateways, which
Right.
is
So
the warehouse basically.
right. In the open source version, the data diffing is only available within the same warehouse. But in our cloud product, we offer cross-database data diffing. So basically, we're able to, across databases, efficiently compute whether or not the tables are the same. And we do that basically by computing hashes over the tables.
And then you fingerprint by ID or something
Exactly.
like that. How efficient is that process?
Yeah, it works pretty well across really large data sets because we basically do like a binary search over the tables using efficient deterministic hashing. And then we can pretty quickly and efficiently get you, samples, rows that don't match.
And this is like, that's a big deal. Like
Yeah.
I've had to implement that myself 10 times for
Yep.
different customers. So like, because you're moving databases and you need to verify that your data, I'm just gonna say SQL Server to a Postgres database, right? Like it's like the same thing. So it's like what you're telling me is that like if I used your cloud version, then I could go against as long as it's a supported database, those types of things. I could verify from point A and compare in point B and ensure that I have the exact same data in both spots.
Exactly. Yeah.
I mean, that's a product by itself.
Right.
Maybe not a gigantic one because it's got such a niche kind of use case, but in part of like the larger ecosystem, that's a thing that would save a lot of time.
Yeah, that product exists, right? The Datafold is that company that really kind of specializes in this field, and I think they do a really good job in creating like a nice kind of UI and feature set around this capability.
Cool. I'll look at data fold when we're done
Yeah.
then. So, is there anything else that SQL Glot provides us? So it supports SQL Mesh with, I can understand SQL. So because SQL Mesh can understand SQL, there's a lot of features that it provides. It provides basic support to SQL Mesh to kind of translate across
Yep.
different data warehouses. Is there anything else that SQL Glot's really doing for people?
So a couple more things. One, it has more than just parsing, right? It can also do like type annotations and logical planning and all those kind of things, which we take advantage of, right? Because with SQL Mesh, you might want to understand how all the types flow through your system. And so we use SQL Glot to do all the type inference and stuff like that.
So that way, if you do a join on like a varchar and an integer, like it's smart enough to figure out like, hey, you got a typing issue.
So right now, like we don't validate that because there's so many different coercion rules. Um, right? And we support many different warehouses, but it's definitely possible. Like we have the architecture for it, but we don't enforce that right now because we don't want to give false positives. We don't want to say, hey, you're not allowed to do this, but in reality, you can. Right? That's a very frustrating experience.
Yeah, like it works on Snowflake, right? So like with
Exactly.
the example I just gave, but it
Right.
might not work on some other one.
Yeah, I've talked to many kind of customers who have tried kind of these other products that say they do a lot of these type checking things. And basically, they're overly strict, right? It says, "Oh, you can't do this. Oh, you can't add an int to a date or something like that." But you can. But then they have to like rewrite their code, and it's really annoying because now there's two different sources of truth. One is their compiler locally, and then one is the actual warehouse, right?
And
It's
the
very
warehouse
frustrating.
is the actual source of truth for this at
Exactly.
the end of the day, right? So
And so getting that to match, especially with a very small team, is a very, very hard task.
well, also there'll be changes and things like that
Exactly.
too. So it's what's the value add to the customer versus like the level of effort for y'all.
That's exactly right. And so, we try to take a balance where we basically tell you something is wrong when we're sure of it. But if we're like not sure or there can be any ambiguity, then we'll let the warehouse decide. And because we have state, it's not so bad when the warehouse tells you because we don't have to start all over again. We just start from where you left off.
Yeah, so it's a 5-second penalty instead of a 20-minute 1 hour
That's exactly
penalty.
right. Yeah.
So now your iteration cycle. So back to developer experience, your iteration cycle's tightened up by the state management. So what's next for SQL Mesh and Tobiko? And is there any like exciting stuff that you want to talk about with like features?
On the open source front, we recently launched a really cool multi-gateway feature. So within one project, right, you can actually pick and choose your engine. And so, for example, you could have a BigQuery main project, but then there are some workloads that you want to use DuckDB for, right? and you can just kind of mix and match. So that's really cool, right? And again, and you can also write that all in BigQuery, but then execute that BigQuery code using DuckDB. And so it just opens up a whole world of possibilities, especially kind of with Tabular's acquisition and Iceberg and data lakes kind of being more and more popular and mainstream. It kind of makes it so that you can pick and choose the right engine for the right workload. So that's something that I'm personally very excited about.
Yeah, I mean, I was talking with some other people at a data warehouse vendor around like how that's really going to enable a lot of utilization that might not have gone to them because with the ability to choose your execution engine, so it's not like your storage and your execution are coupled,
Right.
So like first we separated out the storage and the compute, but now we're separating out like not only is it separated architecturally, it's like logical too. So now I can say, okay, I'm going to use Snowflake on this Iceberg table, or I'm going to use Databricks on this Iceberg table, or I'm going to use DuckDB on this Iceberg table, because it's 10 gigs or something. So I think it like really opens up a lot of things.
Yeah, and then so from the business side of things, or what we call Tobiko Cloud, we're making that what I believe is a really great product and kind of an extension of SQL Mesh, right? So we kind of fundamentally believe that SQL Mesh as an open source product should be a complete and powerful tool. It should be able to work and scale at any company. And we wanted our cloud offering to really extend that and make that an even better experience so that if you want to really scalably run, and operate and have operational excellence and get a bunch of security features, right? That's where you go to Tobiko Cloud. And so we haven't quite publicly announced it yet. We should be announcing it probably in Feb or March of this year. But basically, we have many of the core, aspects of our cloud platform that is really going to make running SQL Mesh more efficient, have more security and oversight, and be more operationally maintainable, right? Giving you runtime histories, costs, failures, right? All the logging, DAG debugging, scheduling, all those kind of things that you would expect out of a robust scheduling platform. So we'll announce that soon.
That's the what we're gonna get about the cloud product right now.
Yeah.
In the future, maybe we can talk about it more.
Sure.
So where can people learn more about Tobiko, which is your company?
We have a growing Slack community. You can join us there at tobikodata.com/Slack. So come there, check us out, say hi. And we'd love to have you be a part of the community.
Awesome. And then there's also the website.
Of course, the website is tobikodata.com, and our open source website is SQLmesh.com.
It's a great tool. Everybody should try it out, especially if you're using DBT, things like that. It solves a lot of problems for you. All right. Thanks, Toby, for coming. Hopefully we get to do something again later once, Tobiko is released, and have a great day.
Thanks for having me.
That's it for this episode of Data BS. If you enjoyed this episode, make sure you subscribe wherever you listen to your podcast and not miss the next one. This episode was sponsored by Cordine, a data consultancy that helps organizations unlock the power of their data. If you have a data challenge, we can help. Visit Cordine.com, CORRDYN.com, to learn more. See you next time.